Okay, this is a second part for analysis of the variance. So last time we talked about the one-way ANOVA, right? Okay, so we to understand the one factor that affect to the dependence, so we call the effect by the treatment, or the independent variable, or the explanatory variable, right? Sometimes we call the predictor, and the dependence we call the response. Okay, so this time we want to extend. So we want to extend the predictor or the independent variable in two steps. So we call this is a two-way or two-way ANOVA. Okay, so suggest that I have to fix levels of the factor in two factors. So we call the factor A and B respectively, and we have A1 to the AK are the K level of the factor A, and the B1 to the BL is level of the factor B by L level. So YJ is what? YJ is the observation response or the dependence variable under the JTH level and ITH of the factor B. Okay, so we will discuss to the two-way ANOVA table. Okay, so you have to see that we have to talk about the column as a treatment by the column. Okay, by the column. And we talk about the block is a row. Okay, by the row. Okay, so now treatment, we have the KTH treatment as a first factor, and the second one we have the LTH block. Okay, so we have the L level of the block. So what is about Y11? Okay, so Y11 is corresponding is the first of the treatment that correspond to the first treatment and the first block. So Y11 is only one unit. Okay, one unit. So in each cell we have only one unit. Okay, you will see that this is a one unit for each cell. So that's why we want to interest that each cell is the one value. Okay. Okay, so what is about the two-way ANOVA? So we have to see the assumption should be the all observation IJ. Okay, so the observation IJ are independent. So we have the different effect. So because we have the level effect of factor A and the factor B. Okay, so and we see the early effect. Okay, at the last one. So the epsilon is Euler is independent and identical distribution with the normal. So we have the Euler is distribute with the normal, and the variance are constant. And we know interaction between A and B. Okay, A and B, no interaction. So we want to test of the significance of the two-way ANOVA. So what we want to do? So we want to test about first the null hypothesis. Okay, for the first factor. So I might say that you can say the first factor as, so we will say the alpha and equal to alpha 2t to the k. So at least one alpha is very different from another. Okay, so and the last one, if we have the factor b, so we requirement that b1 equal to b2 to so on to the bl. Okay, so and okay, sorry for the some mistake symbol. Okay, This is a beta I and beta J. So this is a beta. Okay. So at least one is not equal. So we can say is will reject for the null hypothesis. And we can calculate the correction factor, the CF. So we can identify the new term of the double summation of the Yij. So this term is equal to what? So this term is equal to n, okay? And we have to finding the law of sums of the square is t by the sum of the Yij to the square, okay? So we will go to compute the degree of freedom for the treatment. As last time we have the k minus 1 because we have the k treatment. But this time we have the block is L minus 1 again. And the error is calculated by what? The error term is the degree of freedom is calculated by k minus 1 multiplied by L minus 1. And same thing, you can see the means of the square treatment. So the means of the square treatment, so you can use the sum square treatment divided by the degree of freedom. And the same time is the mean square of the block. You can use the sum square block divided by L minus 1. And the last one is the mean square error is the sum square error divided by the k minus 1 multiplied by the L minus 1. And we have the last one is when you want to calculate the F1 for the treatment, okay? So you can calculate by this formula, and if you want to calculate for the F2, so you can use the mean square block divided by the mean square, okay? Okay, so for discuss, when the mean for each group is different, okay, the mean of each group for different, so you can calculate the number of pairwise by the k combination of 2, so you can get the number of the pairwise is a k times k minus 1 divided by 2. So this formula can calculate by when you want to know the number of the pair, so you can use by k combination 2, okay? Okay, for the LSD statistic can apply when you want to compare with the pairwise different, when you want to test about the mean of the one group is very different from another group, we can apply the multiple combination by the LSD method. And we can calculate by this formula, okay? But we change the degree of freedom of the T-cal like this, okay? So we can change the T-cal statistic depends on the degree of freedom of the mean square error, okay? And we can use the same mean square error again, okay? So that's why we can get the LSD formula like this formula for case of the two-way ANOVA, okay? And the same when we want to set up the hypothesis, so you can apply the same idea of the hypothesis about the one-way ANOVA again, okay? When you want to test the pairwise from the multiple comparison. And I want to say that the total variation, okay? The total variation of the two-way come from what? It come from the sum square of the treatment, so sum square of block and the sum square of the error. So in one way, so you have to see this term and this term because we have the one factor, but now we have the two factor, so we extend the new ones. So this is a second factor, okay? And this is a first factor, okay? Okay, this is a total variation. So I want you to mention for what? Okay, same thing. I want you to mention about the sum square of the total again. Okay, the sum square of the treatment and the sum square of the block that we want to calculate. And you can apply the relation of this formula. So you understand that the sum square total is equal to the sum square of the treatment plus the sum square of the block plus the sum square of the error. So you can calculate the sum square of the error is equal to the sum square total minus the sum square of treatment and minus sum square of the block. Okay. Okay. So I want you to remember 1, 2, and 3, and this relation is 4. Okay. For finish the two-way ANOVA. And if the null hypothesis, okay, has to reject, so we want to extend the LSD multiple comparison to explain. Okay. Okay, so in this course, okay, I want you to recommend to only the treatment. Okay, so we just only test about only the treatment. Okay, so I have to remark for this course. So we want to test only treatment. Okay, so by the column for this course. Okay, so we will set up the hypothesis mu1 equal to mu2 and so on to the mu k. So and for the alternative hypothesis, so the axis the mu j at least one value is different from another value, and we set up the significant level and we have the statistical testing. So that's why we will use the F1 with the mean square treatment and the sum square treatment. Okay, like this. So we will use only F1. Okay, we will use only F1. But when you complete the table, so please do F2 together. Okay, because this is a two-way ANOVA, so you can calculate. Okay, so as you can see, so the degree of freedom of the treatment is k minus 1, and the degree of block is L minus 1 together, and the error is k minus 1 times L minus 1, and the total is k L minus 1 again. So if you want to calculate the sum of the square for each 4 value, so you go back to see the previous formula. And if you want to calculate the mean square treatment, so you can use the sum square treatment divided by the k minus 1. And if you want to calculate the mean square block, so you can use sum square block divided by L minus 1 again. And the last one, you be careful for this. So you can calculate the mean square treatment with the mean square error like this. Okay. So this calculate by this, and this calculate by this. So someone use this divided by this is wrong. Okay. And the last one, you can calculate by the mean square block and use the by F2 is use the mean square like this. Okay. So be careful when you want to complete the table. And so in this case, F1 is less than. For the F critical, so we will accept or fail to reject. And so if it's reject, so it's greater than the critical value. Okay. And we stop by the conclusion at the level significant. Okay. Okay, so now I think that we go to see the example for the two-way ANOVA. And for this is the test of block. I not remark. Okay, no, it's not asked you for the final exam. Okay, for this page, so we can skip. Okay, So I don't want you to use the F2 because I will ask to the F1 for the treatment, but F2 of the FCAL is blocked. So we want to interested for this course. Okay. But another course is special course. So you can go to the deep detail about when you want to test. It's the same idea of when you want to test the treatment, but this time this is a test of the block. Okay. Okay, let's go to see the first example. Okay. Okay, the first example, repute marketing agency in India has a different the training programs. Okay, so for each salesman, the three program are method A, B, C to access the success of program for salesman from each to the program were sent to the fields. So there is a performance in terms of the sale are given the following table. Okay. So you can see the method is the column. Okay. And the salesman is a row. Okay. So now we want to identify. Okay. We want to see that what is the difference among the method. Okay. Among the method. So they said to talk about among the method. So what is the method? So method is a column. We have the three method like this. Okay. So we have to k is equal to 3 because we have the t column. Okay. And the last one, salesman. For salesman, we have the L equal to 4. We have to L box. Okay. For the salesman. Okay. And we finding the sum of this. Okay. So I let. Okay. So I let y, oh sorry, I will use x. Xij be a performance score. Okay. So treatment. So treatment is method. So method. So the method is j equal to 1, 2, 3. And we have k is equal to 3. And for the block. So block is a salesman. Okay. For I is equal to 1, 2, 3, and 4. So we have L equal to 4 right now. Okay. Because this is row and the column. So now I want to calculate. Okay. So I want to calculate the sum of the square right now. Okay. So we want to calculate the sum of the sum xij and the sum of the xij square. Okay. Okay, now I want to calculate. Okay, this is sum of the sum xij is, so this is sum of the xij, right? Okay, so it's a 66. Okay, so now I want to calculate the sum of the sum xij to the power 2. Okay, so I calculate for you is 408. Okay, So we plug in for the sum square of the total. Okay. So we plug in of the sum square of the total is 400 and 8 minus. So be careful of the number of the sample size. Okay, sorry. So the number of the sample size is K times L. So it's 3 times 4 is 12. Okay. Okay, that's why I have the 66 to the power 2 divided by 12. So it's equal to 45. Okay. And I calculate. Okay. I calculate the sum of each treatment. Okay. By the column. Okay. By the column. So we have to see 22, 28, and 16. Okay. So, and can you counting the number of the sample size in column? So we have 1, 2, 3, 4. So n divided by n is 4, right? So for this time we have what? So I have 22 to the power 2 divided by 4 plus 28 to the power 2 divided by 4 plus 16 to the power 2 divided by 4 minus. Okay. 66 to the power 2 divided by 12. So it's equal to the 18. Okay. And the same thing, so you can calculate by the sum of the each row. Okay, for each row. So you can calculate by the 12 to the power 2 divided by 3 plus 22 to the power 2 divided by 3 plus 16 to the power 2 divided by 3 plus 16 divided to the power 2 divided by 3 and minus 66 to the power 2 divided by 12 is equal to 1. And I get the 17. So you go to the sum by row. So you will see this and this and this and this sum by row. And the number of the sample size for each row is 1, 2, 3. Okay. So you can see the number of the sample size for the column is the number of the block is L equal to 4. But number of the row, the sample size is the row is the number of the column K. K is equal to T. That's why we have divided by 4 and T respectively. Okay. So I can calculate the sum of sum square by 45 minus 18 minus 17. So, and I get the sum square. So by the sum square, I get, sorry. Okay, I get number 10. Okay. Okay. Now we want to construct. We want to construct the two-way ANOVA. Okay. Okay. So I want to test by the treatment. So we have the mu1. Mu1 is equal to mu2 is equal to the mu3. So there exists mu j, right? At least one value is differ from another value. So alpha is 0.01. And we calculate by the F-cal. So by the mean square treatment with the mean square error. Okay. So can you remember about the degree of freedom of the method, right? Okay. So this is a what? This is a 3, sorry. Is a 2, right? Is 2 come from what? T minus 1. Okay. And for the Selman is 3 is come from what? Is a 4 minus 1. And the other is come from 6. So 6 is come from 3 minus 1 and 4 minus 1, right? And we can sum of the degree of freedom is 2 plus t plus 6 is 11, right? And the sum of the square of the treatment is 18, and the block by Selmans is 17, and the total is 45. So that's why we get the sum square error is 10. Okay. So what is a mean square treatment? So you can use 18 divided by 2 is 9. Okay. And for the Selman, you will use a 17 divided by t is 5.67. And the last one of the error, so you can use 10 divided by 6. So you will get 1.67. So in this cell, so please comment. So this is mean square error we will use in the LSC method, right? And I want to calculate the F1 score. So F1 can calculate F1, so is equal to, so you will use 9 divided by 1.67. So it's equal to, so moment we use the calculator first. So it's 5.39. And the F2 is equal to, F2 is come from 5.67 divided by 1.67 is 3.40. Okay. Okay, for the decision. So you can calculate the F by 1 minus alpha with the degree of freedom k minus 1 and L minus 1. So it's equal to F of 0.99 with the degree of freedom to 6. Okay. Okay, so we go to the statistical table about the F. We go to see the F with the probability of 0.99, and the degree of freedom is 2 and 6. 2 and 6. Okay. 2 is here and 6 is here. Like this is 10.92. So we get 10.92. So if F critical region is greater than 10.92, we will reject. So we see that F cal is less than 10.92. Then we fail to reject F0. Okay. And this is a 10.92, and we get the F cal like this. Okay. So what they want to see, so they ask you, do we have the difference among the method? Okay. At the level of significant 0.01, we don't have an evidence to reject among to reject that we have the different among method. Okay. Okay, we don't have the evidence to reject. Okay, so it means we accept. So we don't reject the H0. So the method is not different. Okay. So if we fail to reject, so we don't use the LSD because we don't use the LSD, so we don't have the difference. So if we reject, so then we get the difference among the treatment. Okay. So we go to the next. Okay, we go to the next. Okay. So please read carefully. Okay. Okay, we the example. We see the example 7.5. Okay, so the illness caused by the virus, okay, in a city concerning some restaurant inspector is not consistent with their evaluation of the cleanness of restaurant. In order to investigate this possibility, the director has 5 restaurant inspector to grade. Okay. And the cleanness of the 3 restaurants shown by the result below. Okay. So you can see the restaurant the restaurant is the column and the inspector as a row, right? So what we want? So they want to ask, is there a significant, okay, difference between the restaurant at the 0.05 level of significance? So if you find a different, perform the pairwise test to determine whether a different lies, okay? Okay, so we want to see the difference, right? Hmm. So maybe we will check the sum of the sum of the row and the sum of the column first. Maybe I think something will wrong. Okay, so we want to check again. Okay, so we want to check by the row first. Okay, that's, I think something will wrong now. So we will check the row, the sum of the row and the sum of the column, and the sum of the sum for each row and column. Okay, let me check. Okay, so for the first row, I have the 210. Okay, get 208. I get 212. I get 211. I get 225 again. Okay, I get 354. I get 310. I get 402. So I finding the sum of the sum for row. I get 1066. Okay. Okay, let me see first. So this is a restaurant and this is the inspector. So the restaurant have the K is equal to 3 treatment. And the inspector, we have the L equal to 4. 1, 2, 3, 1, 2, 3, 4, 5. Okay. So this is treatment and this is block. Now we go back to C, so to identify. So let, okay, let Xij be the score, the cleanness score, right? I think the cleanness score, cleanliness score. Okay. So, and the treatment is restaurant J is equal to 1, 2, 3. Sorry. And block. So block is what? So block is the inspector. So I is equal to 1, 2, 3, 4, and 5. So it means K is equal to 3 and L is equal to 5. Yeah. Okay, I'm finding the sum of the Xij and the sum of the Xij to the square, and n is equal to KL. Okay, this is a 1066, and the sum of the x square is the 76,988, and we have the 3 times 5 is 15 right now. Okay, I have to plug in this value for the sum square total. So is minus so is equal to 1, 2, 3, 0.39 933, right? And the sum of square of the treatment. So we will use the sum of the row for each column, sum of the column for each column. And we have 354 to the power 2 divided by 5 plus 310 to the power 2 divided by 5 plus 402 to the power 2 divided by 5 minus. Okay, we have the 1066 to the power 2 divided by 15, so it's equal to x 46.399. Okay, and we calculate about the block. Okay, so we have to calculate 210 to the power 2 divided by 3 plus by the sum of each row 20x to the power 2 divided by 3 plus 212 to the power 2 divided by 3 plus 211 to the power 2 divided by 3 plus 225 to the power 2 divided by 3 minus 1066 to the power 2 divided by 15, and we get 60.399 again. And we calculate the sum of the square total is 1230.3933 minus x 46.933 minus 60.933 again. Okay. So I get 323.067. Okay. 067. So we will use 3 digits, right? Okay, now, so I have to set up the hypothesis testing right now. Okay, so we have to test about the mean of the treatment is different or not. So we set up the mu1 is equal to the mu2 is equal to the mu3. So at least, sorry, there exists at least mu j is differ from another values. Okay. Okay. So we have to set up the level of the significance. So the level of significance is 0.05, and we have to use the 2 ANOVA. Okay. So if you remember that, we know the restaurant is K, so the degree of freedom is 2 by K minus 1 is 3 minus 1. So the inspector is L minus 1 is 5 minus 1 is 4. And 2 times 4 is 8. So we have to 14 by the total degree of freedom. Okay. So, and let me check for the sum square of the treatment. So is what? Treatment. And the block. And the error. And we have to see the sum square total. Okay. For in case of the means, sorry, the means square treatment. So we get the 423.467, and we have the mean square box divided by 4 is a 15.233. Okay, and the mean square error okay. So this is the mean square of the error when you want to use for the test of the LSD test. So this is the mean square error. So for the F1, okay, so you calculate the mean square error divided by the degree of the freedom, right? For the mean square error. Oh, sorry. So you want to calculate the F1, sorry. So the F1 we use a 423.467 divided by the mean square error. So we get maybe I think I missed something. Okay, I get 10.4x6 and F2. So F2 you use a 15.233 divided by 40.383. So you get 0.37 and 7. Okay. Okay, right now we go to see the critical value. And K minus 1 times L minus 1 again. Is 0.95 with 2a. Okay. Okay. Two a. Okay, we go to see the stat table. 0.95 and 2a. 2 and a is 4.46. Okay, 4.46. 4.46. Okay. Okay, F is greater than 4.46. Okay, so this is 423.67 divided by 40.383 is equal to 10.4x6. So and we have the F cal is greater than here. Okay. So we see that F1 cal greater than 4.46, then we reject S0. Okay. S0. So by the conclusion, so at the level of significance, 0.05. The average grade of the cleanness of 3 restaurants are different. Okay. Okay, now we see that we have the different among the treatment, so we go to the next process right now. Okay, so the second question go that, so if we have to the the different among the mean of the treatment, so we can use to finding the LSD pairwise test. So I calculate the LSD test. Okay, so we have the 3 pairwise. Okay, and now I calculate the LSD statistic value first. So alpha is 0.05, so we have to see the T subscript 0.975 with the degree of freedom K minus 1 and L minus 1 is 2 times 4 is 8. And we have to see the square root of the mean square error. So the mean square error is 40 what? 383, right? 383. And so to see that the number of the sample size for each treatment is equal. So we have how many the sample size of treatment? So you can see this is one of the treatment, and this is one. So it's 1, 2, 3, 4, 5. Okay. So that's why we use 1 divided by 5. 1 divided by 5 plus 1 divided by 5. Okay. And right now we will open. So we will to open the T table right now because we want to know the T statistic value. Okay. Okay. So T is 0.975. We go to open the T statistic. Okay, with the degree of freedom of 8. Okay, we use this. Is 2.306. Okay, so we to calculate this point. So please recheck for each step. Okay, I get 9.268. Okay. Now we calculate the sample mean for each treatment right now. Okay. So I go to finding the sum by the column. Okay. divided by 5. Okay. So we can calculate by the mean first. Okay. $62. Okay. 80.4. Okay. Now we want to compare. Okay. We can calculate by this difference of the mean. Okay. So I calculate the absolute of x bar 1 minus x bar 2. So I have x bar 1 minus 62 is equal to what? 8.8. Okay. And absolute of x bar 1 minus x bar 3 is equal to absolute of 70.8 minus 80.4 is equal to 9.6. So we check again. Okay. Now the absolute of x bar 2 minus x bar 3 is equal to. So is equal to 18.4. So you can see that this is less than the LSD. So we fail to reject A0. And this is greater than LSD. So we reject S0. This is greater than LSD. So we reject S0. Okay. Okay, now, so at the level of significance 0.05, we conclude that first, so what is the cholesterol? Sorry, we see the cleanness. Okay, XYZ. The average score of cleanliness cholesterol X is not differ from Y. Okay, from Y. Okay. Second, is what? So the average score of the restaurant X is differ from C. Okay, and the last one, this is a Y. Okay. Okay, we have one is reject. Okay, because it's less than the LSC value. Okay, so we can conclusion like this. Okay, so or you want to by the how to say, you can order X2, so by the bar diagram, so X bar 2, X bar 1, X bar 3, X bar 1, X bar 3. Okay, so you can see that we have the bar diagram, right? Okay, 1 and 2 is not different, right? So this is a group because, so this is a not different. Okay, this is not different. So the good restaurant is restaurant C because we have the highest average score of the cleanliness. Okay, so that we can infer like this. Okay. Okay. Okay, for I think maybe for the last one, for this example. Okay, go. So in the experiments investigating about the wrapping of the copper plate, the two factors that were temperature and the copper contents of the plate. The response variable was a measure of amount of the wrapping. The resultant data as follow by the table below. Okay, so we setting all necessary assumption analysis for the significant effect at the significant level. Okay, for this example, we just only investigate among the treatment by the copper. Okay, so now we have the copper content percentage and the temperature. So this is a treatment and this is a block right now. Okay, so let's Xij be the amount of warping, sorry. So treatment is copper contents by the percentage, and the block is the temperature by the degree of Celsius. So I think the sum of the row and the sum of the column is okay right now. Okay. but maybe something wrong. We will recheck together, right? So we calculate the sum of the sum xij to the square, sorry, and the sum of the sum xij to the square, and the total sample size is k times L. Okay. So treatment I is 1, 2, 3, 4, and sorry, J, right? J treatment, and I is equal to 1, 2, 3, and 4 together. Okay, so we have 4 times 4 is a 16, right? And this show is the sum of the xij is 3, 3, 4. Okay, so we calculate by the sum of the sum square. So we will calculate the sum of the square. Okay. So please recheck to me, okay? Okay. So I have the 7,456. Okay. So we plug in this. Okay. Please recheck to me together, right? Okay. For 7,456 minus 334 to the power 2 divided by 16. So I received 483.75. Okay. And we finding the sum of the column to the power 2 divided by sample size. Okay. So what is the column numbers? How many sample size is 4? Okay. Plus 85 plus minus to the power 2 and 16. Okay, I get 400 3025. Okay. And by the sum of the block. Okay. You go to finding the sum of the row. Divided by 4 again. Plus minus. Okay. It's 46.25. Okay. So for the sum square total, we have we want to calculate the sum square, so we use the sum square total minus minus 46. I use a calculator right now. It's 7.25. Okay. Okay, we can go to the part of hypothesis testing. Yeah. Yeah. So we have the formula, right? mu1 is equal to mu2 is equal to mu3 is equal to mu4, and there exists at least mu j is differ from another value. Okay. So the significant level is alpha is 0.10. Okay, now we have to see the copper content is 4 minus 1 is 3, the temperature is 3, again the error is T times T is 9. So 3 plus T is 6, 6 plus 9 is 50. So by the by the sum square of the treatment right now, we go back to C. Okay. And we have to for the block 2, 5. And for the other, and we have the total is point, sorry, 7.5. For the mean square treatment. Okay, for mean square treatment, you have to use this divided by the degree of freedom 3. And the mean square of the block divided by 3 again. And the mean square of the error. Okay. Okay, for the F1. So this is the mean square error. Yeah. F1 is equal to is 177 and F2 is equal to okay. So we go to open the F critical value. F of 1 minus alpha divided by K minus 1 times L minus 1 3 and 9. Okay. Three and 9. Three and 9 is this. Okay. 2.81. Okay. So F cal, oh, is here, is right? Okay. So we see that F1 cal is greater than 2.81. So then we reject A0. Okay. Okay, we conclude that at the level of significance 0.10, the copper contains the percentage copper content is different. Okay. Okay, now we see that the percentage of the copper content is very different. Okay. So we go to see the LSD test right now. Okay. So we have to see the, okay, this is a 4 factorial right now, and this is a 4 minus 2 factorial and 2 factorials. So you will get 6 pairwise. Okay. So we calculate by the LSD statistic right now. Okay. And we get the T of 0.95. Okay. Okay, now with the degree of freedom 9. Okay. Times for the mean square error is 0.806. So we have 1 divided by 4 plus 1 divided by 4. Okay. Okay. So we will see the value of the T. Okay, value of the T. 0.95 with 9 here. Okay. Okay. So it's 1.833 times the square root of 0.83 x06 times. Okay, so we get the 1.4. Okay. So for the sum of the sample mean, right? So we go to the sum by the column. Sum by the column like this. Okay. So we get 60 divided by 4. 73 divided by 4. 85 divided by 4. And 116 divided by 4. So this is 15 right now. Okay. So we calculate the LSD and we will compare together, right? Okay, maybe I use this. Okay, this is greater than the LSD. So we reject as 0. Okay. Next, absolute x1 minus x3 is the absolute 15 minus. Okay. Is 6.25. So it's greater than LSD. So we reject as 0. Okay. And the absolute x bar 1 minus x bar 4 go to 15 minus 29. Okay. 14. So it's greater than LSD. So we reject as 0. So what is mu2 and mu3? Minus. So it's 3. So it's LSD again. So it's greater than. So we reject as 0. Now is absolute x bar 2 minus absolute x, x bar 4 minus 29. So it's greater than the LSD. So we reject as 0. So it's x bar 3 minus x bar 4. is equal to, so is 7.75, so is greater than the LSD. So we reject. Is 0. Okay, the last one. So at the level so I want to know the symbol of the 40%, 60, 80, 100. 40% is differ from 60. Okay. First, for 80. Okay. This is from 100. Okay. Okay. So we go to 60% different from 80% and 60% different from 100%. And the last one is 80% different from the 100%. Okay, like this. Okay, this is a conclusion because we have different for each copper content, right? So, okay, that's it. Okay. So we finish the chapter 7 for this time. Okay. So hope you review for this chapter and recheck by the exercise by yourself. Okay, thank you.